When determining whether the series converges or diverges, the really big factor here is this term right here, which tells us that we have an alternating series. This term right here will make every other term negative and every other term positive. That's what an alternating series is. Now, if all we have to do is answer the question, does this series converge or diverge, then all we have to do is ask the question, is the limit of the term inside of the series going to 0? And the answer to this question is really quickly yes. As n goes to infinity, the denominator goes to infinity. 1 over infinity just gives us 0. So our series converges by the alternating series test, and we are finished. However, we could ask a follow-up question. Does this series converge absolutely? All that means is, if we take an absolute value of every single term in this series, in other words, if we get rid of the alternating part, does the series still converge? Well, if we get rid of all those negative signs, this is the series we're left with. And we should expect this series to behave like a 1 over n squared series, because that is the highest power term in this series here. And a 1 over n squared series converges, because that is a p series with p equals 2. Now, technically comparing these two series would involve either a direct comparison test or a limit comparison test. Doing a limit comparison test means dividing the term in our series by the term in the series we're comparing it to, dividing those fractions, and taking a limit as n goes to infinity gives us a big 1/7. Now again, that number is finite and that number is not 0. Therefore, the limit comparison test tells us that these two series either both converge or both diverge. Since we know that this series converges, then we know that our series converges as well. So going back to the original problem, if we take the absolute value of each one of these terms in this series, that series converges. That means that our series converges absolutely. So the answer to the bonus question here is yes, this series also converges absolutely. That is a bit stronger of a statement than a series just converging. We already knew that our series converged, and now we know that it converges absolutely. Okay, I hope that helped you out, and I hope that you check out the next video in this playlist.